Here's another trig example. We have the antiderivative of the secant cubed of x times the tangent of x. So we have some choices here in terms of the kinds of substitutions that we can make. We could try to choose tangent, we could try to choose secant, we could try to choose secant squared. There are a variety of different things. And one of the things you'll need to get a little bit used to when you go through this process is you may pick things that don't work. And that's just part of integration. That's just part sometimes of math as you go deeper into math, is you have to be ready to fail sometimes and go through some trial and error processes. The more of the trial and error process that you go through with integrals, the better you'll get at integrals, the better you'll get at making a good choice earlier on. But if you're new to it, and I'm assuming you are, you may fail a few times in your choices. So what I look at when I see something like this is the fact that I have secants and tangents. I know the derivative of tangent is secant squared, so that's an interesting relationship. I also know the derivative of secant is secant tangent. And if I consider the derivative of tangent to be secant squared, well, there's too many secants there, secant cubed, so that doesn't really help me a lot. But if I consider the fact that the derivative of secant is secant tangent, I can split things up to work a little bit better. So let's first take a look at this as the antiderivative of secant squared of x times secant x tangent x dx. And then let's look at the fact that if we let u be equal to the secant of x, du is equal to the secant of x times the tangent of x dx. Now you may be looking at that and saying, well, you don't have enough secants. There's 3 secants there. You let your u only be secant squared. But remember, when I replace secant with u, I'll get u squared there, and that's fine. That's something that I know how to take antiderivatives of. So these things can look a little bit funny in the trig world, especially I think because of the way that we tend to write trig exponents. But sometimes just follow them through and see what happens. So I don't need to do anything with the constants here. I can go straight to my substitution. So I'm going to end up with the antiderivative of u squared, that's secant squared, times du, that's the secant x tangent x dx. Antiderivative is 1/3 u to the third plus c, and therefore my answer is 1/3 secant x cubed plus c, or if you prefer, 1/3 secant cubed x plus 3. Go ahead and see if what happens if you take the derivative of 1/3 secant cubed x plus c using the chain rule. I suggest using it in the first way that I wrote it, with the parentheses, secant x inside those parentheses to the third power, a little bit easier to apply the chain rule, and verify for yourself that you do get back to that original integrand there.